trying to convert the pressure of a bike tire. Has anyone done that one? Or want to give me some hints on how we're going to do it? Gets very quiet. So when I get a question like this, any sort of question that's sort of similar, what I generally do is just write down the information I've got. So I'm just going to write down the information I have. So I have 120 pounds and then inches cubed. And what I want at the end of it is grams and centimeters cubed. So I need to do a couple of changes. I need to convert pounds to grams, and I need to convert inches cubed to centimeters cubed. So let's do the inches cubed first. I think I can. So I want to have centimeters cubed on the bottom, and I want to have inches cubed on the top so I can get rid of it. So I'm going to put my inches cubed up here. And then what is equal to 1 inch? Anyone remember what the change is? What the conversion factor is for 1 inch?
2.5 centimeters.
That's right, exactly. So 2.54 centimeters. Now, the most common mistake that students make and that I make is that we figure if 1 inch is equal to 2.54 centimeters, then 1 inch cubed is equal to 2.54 centimeters cubed. That is not the case, because we need to, because when we're squaring or cubing or taking to the fourth power, whatever it is we're doing that, if it's a measurement, we're doing it both to the number and we're doing it to the unit. So if we have 1 inch cubed, this is actually like this. That is the conversion to make. So we need to cube both the 2.54 and the centimeters. That is the actual conversion. Cube everything, the number and the unit. So the next thing we need to do is convert pounds to grams. Excuse me. I think the easiest conversion is probably kilograms to pounds. Does anyone have that? How many kilograms are in a pound?
2.2.
Is that it? We don't have anything with more significant
2.2
digits?
kilograms equals 1 pound.
Sorry?
2.2 kilograms is equal to 1 pound.
So we don't have anything with more significant digits than 2.2? Is that in the list? The I should have pulled that up. The list that I gave everyone?
Is it 0.454?
0.454. Oh,
kilograms? Are we doing pounds?
yes,
Did
so
you
it's
say pound?
454 grams in a pound. That is right. So we can do it that way. Pounds, just pounds directly into grams. That works. So I want, let me just erase this for a second. Oop. That's actually, oops, what happened here? Hello? Hello?
Do you hear us?
I do. It's like something happened to my computer.
I think you're freezing out.
My computer just died or something.
I don't know if it's just me, but I can't. Like your screen looks black.
Yeah, it is black. Okay, what I'm going to try and reboot this and come back in a minute. Okay, give me a minute to try and.
Okay.
This is like the last thing I need. Go.
I think it's fixed now.
Yeah, now it's working.
Yeah.
It's flashing.
Oh yeah, it's working now.
Weird. Okay. Me. Resume. Okay. Oh, that was exciting. Okay.
I have a quick question,
Yes.
Professor.
Yeah.
For the for the conversion factors, I think last class you had mentioned that some of the metric conversions weren't on the chart that we had in our syllabus. Can we just Google anything that is online and use that kind of chart, or is there?
Oh, of course, except for tests.
Yeah,
Yeah.
but we can just use any general one when
Oh,
we're
of course. Yeah. Of course. Yeah. That particular list was basically given. We created that for students taking tests, so they wouldn't have to, memorize all that stuff. But yeah, if you're doing a problem set, or if you're doing a lab report or anything, yeah, look up whatever you like. It's only for exams. You can't do that. So yeah, feel free. So we had 120 pounds over inches cubed. And then we converted our inches cubed to centimeters cubed. And then we needed to convert this pounds to grams. And it was pointed out that there is 454 grams in 1 pound.
Hi, so I have a question.
Mm-hmm.
On the reference sheet, it says to pounds to grams, it's 453.59 grams.
Oh, even better.
So do we just follow that, or do we do the 454?
Whatever it says there. So, I mean,
Oh,
remember, we want to keep as many significant digits as we can. So
okay.
so in your conversions, you want to use as many significant digits as you can, because that way you preserve the precision of the original measurement. So it's 453.59.
0.59.
Excellent. Okay, now we just check and see if we have the right units. So pounds we have up here, pounds we have down there, and inches cubed. And what we're left with is grams on top, and centimeters cubed on the bottom. So all we have to do is multiply 120 by 453.59, and then divide that by 2.54 cubed, not 2.54, but 2.54 to the third power. So what number is that? Somebody better get this before I do.
Is it 3321.571?
So what do you have? 3.
Oh, the cube is cube of 2.54 is 16.387064.
Okay.
It's just for the cube.
So your final answer, I had it here a second ago. So what was it? 332.
1.571.
571 grams per cubic centimeter. Now we have to ask how many significant digits should we report? So we have 5 in our conversion here. So we can't have more than 5. And remember, how many significant digits here?
3.
3.
You sure?
Because of the period. Or yeah.
In the 2.54, how many significant digits?
3.
3. Oh no.
That one's the tricky one. 1 inch is exactly 2.54 centimeters. So that
Infinite.
is an infinite number of significant digits. That's weird, right? I still find that bizarre that's the case, but those two are exactly the same. So that's pretty much the only number where that's going to show up when we're doing these conversions. That is an infinite number. So really, we're going to be limited by the original number here, 120 pounds. So how many significant digits in the 120?
3.
3.
That's right, because there's a period at the end. Excellent. So here's our answer. And we need to reduce that to 3 significant digits. So what's the final answer?
3. Oh.
So here's our number. We have 1, 2, 3. So here's our, so that 2 is our last significant digit. So what's our final answer?
3.32 times 10 to the third power.
Yeah, if you want to put it in, if you want to put it in
Yeah.
scientific notation, that's right.
Uh-huh.
Or just 3,320. It's the same number.
Okay.
That's right. And then remember, in your answer, you always have to have the units. So have the grams per centimeters cubed there. Okay. So
In this case,
oh, go ahead.
so in that case, though, that since that's the final answer, that's the number of significant figures, and there's no decimal that goes behind it.
That's right. If you put a decimal there, that would be
Then that
4
would be the infinite
significant
amount of
digits.
numbers.
That's not right.
Okay.
There's only 3. So you get rid of the decimal, because remember, a trailing 0 before the decimal is not significant. If there's a decimal point, that makes it significant. So if it's just 3320, that means we're counting in tens. The next number up from that would be 3330 and then 3340. Yeah. All right, so let's look at the next one here.
I have a quick
Oh,
question.
okay.
For
Love quick questions.
2A, so the answer I ended up getting was 2,400, but then you wanted it in scientific notation. So,
Oh, are these for scientific notation? I didn't notice that.
no, I was talking about question 2.
Oh, okay.
So my answer was 2,400, and then in order to write it in scientific notation, is it correct to write 2.4 times 10 to the second power, or can I write 2.400 times 10 to the second power?
How many significant digits are you allowed?
Or
4. Then it would be 2.400. Yeah.
oh, okay.
Yeah, because anytime you use scientific notation, that the first number before the exponent, I can't remember what it's called all of a sudden. That first number has all the significant digits for the actual number. So if your actual number has 6 significant digits, then that number in scientific notation has to have 6 digits too.
And then like for 1D, it's 202.00. So those 2 zeros at the end of the decimal point, when I put in scientific notation, would it be 2.0200 times 10 to the second power? Or
It would be
2.0
2.0200.
times 10 to the negative 10 to the second power.
Yeah.
Oh, okay.
Yeah.
Because I wasn't sure if we had to still include those 2 zeros after the 2.02.
You definitely have to, because 202.00, whoever measured that number was able to measure it with that amount of precision.
Okay.
So we need to reflect that when we're doing calculations. So if you're going to, so you need to have all 5 significant digits there, because
So
there's,
if we,
there's a difference between this number and this number. One is much more accurate than the other one, or much more precise, I should say. I don't know if they're accurate or not. It could be completely inaccurate, but one's more precise.
so if we wrote, if you know, during an exam, if we ended up writing 2.02 times 10 to the second, that would be wrong because it's
Right,
not
yeah,
precise.
you'd be docked a couple points for that. Like,
Okay.
I'd say if it was worth 4 points, you probably would get like 3.
Okay.
Yeah, because obviously, you know, well, maybe even 2, because yeah, the significant digits are super, super important when
Okay.
when you're doing calculations. So yeah, so that's a good thing to remember.
And then like in general with these problems, when it like you know number 3, 4, 5, 6, in terms of significant, we have to round off the final answer depending on the number of significant digits are in each of the numbers presented in the problem, correct?
That's right. So
Okay.
basically, if it's all division and multiplication, then basically you're limited by the least precise number.
Okay.
So if the least precise number has 2 significant figures, then your final answer needs to have that many as well.
Okay.
But if it's addition and subtraction, then you have to do the addition and subtraction first.
Okay.
Okay. All right. All right. So next one. So how do we start with this? We need a mass of gasoline. So our final. So let's write down what we're given. So we're given 16.0 gallons. Pretty much a typical tank, maybe even a little bigger than a typical tank these days. And we need to convert that into kilograms of gasoline. So what's the first thing we need to do with this gallons? What do we do with that?
When you convert gallons to grams,
How do we convert gallons to grams? Gallons is a unit of volume.
Convert gallons to ml.
Convert gallons to liters or to milliliters. Right. I would probably just convert it to liters first, because I think there is a straightforward conversion. Does anyone have the chart in front of them? Is there a gallons to liters conversion?
I only see gallons to quarts.
Yeah, that's helpful.
Yeah.
That's what
All
I
right.
was asking earlier, because I think the last class you mentioned that there are some missing conversions.
Oh
and
yeah,
we were
that's a
going to add
classic
on
one.
to it. So yeah.
Yeah, good. Yeah, so good. If someone could look that up, just liters to gallons, gallons to liters, one or the other. I think it's around 4, a little more than 4, but I don't know it precisely.
I'm getting 1 gallon is equivalent to 3.79 liters. Is that correct?
I've got 3.321 from Audrey. Does that sound right? 3 that seems small. I think it's more like 4.
Professor, that was the from letter F.
Oh. Okay.
So
So I was right. It does seem a little small. So how many liters do we have in a gallon then? Yeah, I would look it up myself, but I'm afraid if I switch screens, it's going to explode on me or something. 3.79 liters. Okay, thank you. 3.79 liters. Okay, then we want milliliters, right? Not liters. So the next conversion I would do is convert liters to milliliters. So we want milliliters on the top here and liters on the bottom. So how many milliliters are there in a liter?
1,000.
1,000, that's right. So that gives us, so if we just do this calculation, that gives us the number of milliliters. So how many milliliters is that? Quite a few. How many milliliters do we have?
I got 60,640.
I did too. So I think if either we both made the same mistake or we got that right. So 60,640 milliliters. Now here we've got density. Now, density is a ratio of something. And this, we're going to be doing this experiment this week, actually, calculating density. What is it a ratio of? You can see that it's a ratio of something. It's a ratio of what? It's grams over milliliters. So what is it a ratio of? It's a measurement of two different things.
Mass and volume.
That's right, exactly. So it is a ratio of mass over volume. And you can see that it's less than 1. So does that mean it would float on top of water or would it sink into water? What's the density of water?
1.00.
1, that's right. Water is 1 gram per mil. So is gasoline going to float or sink when you mix it with water?
Well,
It's going to float, exactly. So we've got 60,640 mils, and we want to convert that into a mass. So basically, we use density because density is the ratio of mass to volume. So if we have a volume, we want to convert it to a mass, we need the density. So here is our 6,640 milliliters. And again, we never divide. I never want to see division. Always multiply, because that way you can keep track of the units. So our density is 0.671 grams in 1 ml. So that gets rid of our milliliters, but we don't want the mass in grams. Remember, the question asks you in kilograms. So we need to convert we need to finish with kilograms. So I'm going to put kilograms on top and grams on the bottom. So what's my conversion of grams to kilograms?
1 kilogram is equivalent to 1,000 grams.
That's right, exactly. Kilo means 1,000. So that gets rid of my grams. I got rid of my mils. So there's only one unit left, and that is kilograms. So it's basically 60,640 times 0.671 divided by 1,000. So what's my final answer? 40. Thanks, Lorenzo. 40.68944 kilograms. Is that, but Lorenzo, is that your final answer? So I might have to get upset if that's your final answer. Now you put the unit in there, that's good, but you're only going to get partial credit. What's wrong with that? What's wrong with that answer? What is it?
Significant.
Yeah, there's too many significant digits, right? So how many significant digits should we have? Well, we go back and we see which one of these is limiting us. So we start with the actual question itself. So I've got 16.0. How many significant digits there?
3.
3. And my density, I've got 0.671. How many significant digits there?
3 also.
3. And I think we use more than that to do the other conversions. And this is exact because there's exactly 1,000 grams in 1 kilogram. So we don't have to worry about that one. But so there's 3. So we need to reduce this to 3 significant digits. So we 1, 2, 3. So what's my final answer going to be?
40.7.
That is correct. Yeah, we just look at the next number. We don't worry about those. We just look at the next number and it's at 8. It's bigger than 4. 40.7 kilograms. Right. Excellent work.
For this equation, did you just, so you
Sorry?
converted the 16, for this equation problem, you converted the 16 gallons all the way to milliliters, and then from the milliliters, you converted that to kilometers. But I thought that because it gave you the density, you just multiplied whatever the density was with whatever the volume was, and then you got the mass.
That's what we've done.
Oh, okay.
But we wanted the final mass to be in kilograms, not grams.
Oh, I see. Okay.
That's the only difference.
Okay.
So if it was in grams, we would have had 40,689.49 grams. So then we would have just then reduced that to 3 significant digits. And that would have been 40,700 grams. So it's the same answer. 40,700 grams is the same as 40.7 kilograms. It's the same thing. Yeah, you just have to carefully read the questions because like I've mentioned many times, chemistry teachers are evil. And so we will put in things like that, like little things like this. So, you've done everything exactly right. And then you give the answer, but it's not in the right unit. So yeah, we just do that to be mean. It's the only thing that gives our life any pleasure. Okay.
So you're a mean instructor then.
Well, of course. All right, number 4. Has anyone tried this on yet? Because this one, there's some information in this one that we need that isn't in the question that you have to look up. So let's just write down what we have. So we have aluminum rod. It is, make that a little bit bigger. It is 4.85 meters long. And it has a radius of 6.25 millimeters. So it's asking you, how much aluminum do you need to make an aluminum rod this size? And so basically what we need to do is figure out what the volume of that rod is. What's the volume of the rod? But that's not enough information, right? So that would give us a volume of aluminum. How are we going to figure out what the mass is? We're missing a piece of information.
Density of aluminum.
That's right. We don't have the density of aluminum. So we need someone to find us the density of aluminum.
It's 2.702 grams over centimeters cubed.
Excellent. So it's 2.702
2.
grams per
Yes.
cubic centimeter. So you can see we're probably going to need to convert our whatever we get our volume in. We're probably going to want to get it in cubic centimeters because that's what our density is in. So what I would do is convert all of my length, all my measurements into centimeters. Because then when I do my calculation, I'll get centimeters cubed. Does that make sense? Because the volume is pi times the square of the radius. The square of the radius is in millimeters times the length. And the length is in meters. So if we don't do any conversions, we're going to get some really weird units of the millimeters squared meters. That doesn't make any sense. So we have to have them all in the same unit. And since we're going to need cubic centimeters, why not just convert everything to centimeters? Does that sound like a good way to proceed?
Yes.
Okay, good. I'm glad you're in agreement. All right, so how are we going to convert our length? This is our length. How are we going to convert our length to centimeters? So I want to multiply this by something to give me centimeters. So what's my conversion here? I'm going to get rid of meters. I'm going to replace it with centimeters. How many centimeters in a meter?
$100.
100, that's right. Centi means 1/100th. So it means there's 100 of those in a meter. So 100. So we've got 485 centimeters long. That's our length. Our radius is 6.25 millimeters. And so here is another classic way we, make mistakes doing this. So we want to convert millimeters again to centimeters. So here's centimeters, here's millimeters. What's the conversion between centimeters and millimeters? Which one's bigger?
Centimeters.
Centimeters is bigger, that's right. And so we know that there's more than 1 millimeter in a centimeter. So what's the conversion? How many millimeters are there in a centimeter?
10.
10. Man, you guys are killing it. Yeah, exactly. And it's since the metrics, this makes it easy because since the metric system is all based on tens, every conversion you do in the metric system is going to be some amount of tens. 10 or 100 or 1,000 or 10,000 or a million or a billion or whatever it is, it's always going to be a multiple of 10. And there's 100 centimeters in a meter, but there's 1,000 millimeters in a meter. So millimeters are 10 times smaller. So there's 10 of them in 1 centimeter. So that gives us 0.625 centimeters. We basically just divide it by 10. So now we just plug these into our equation. So we have pi, and your calculator probably has pi on it. And then 0.625 centimeters. And remember, we're going to square that. So we're going to square both the number and the unit. And we're going to multiply that by 485 centimeters. So how many, what's our volume? A, what's our volume? B, what are the units? Oh, damn it. Here we go. All right, so work out, just do the calculation. Tell me what the number is and what the unit is. Hopefully everybody knows what pi is, right? This isn't new information.
Would it be 595 centimeters cubed?
Let me double check. Let me see. Times 0.65 times 485. Yep, I got 595.184. So, oops. Remember, so when you're doing these calculations, leave as many, don't round before you get to the end. So if your calculator has, like, 10 significant digits, leave them there. Just keep doing your calculation. So I've got 595.184. And what's the unit?
Would it be centimeters cubed?
It would be, right, because we have centimeters here, and we've squared that. So we've multiplied centimeters by centimeters, and then we multiplied again by centimeters. So we got centimeters times centimeters times centimeters. That's 3 of them. So that's centimeters cubed. So now we take into consideration our density. And we want a mass. Hello. So we want a mass, but it doesn't say what units. So you can basically use any units you want. You can convert this to pounds if you want, though I don't know why you would. So we just plug in our density, and it is 2.702 grams per centimeters cubed. So our centimeters cubed cancel out, and we left with grams. That's a unit of mass, so we're good to go. So what's our final answer?
Um, 1606.99.
Was it 6006 point?
No, I got 1606.
Oh, 1606. Oops. Okay. So 1606. Okay. Point what?
9968.
9968 grams. All right. So how many significant digits should we be using in this answer?
4.
Okay. Where did you get 4? There's 4 in the density. There's definitely 4 in the density.
3
There's 3. Where do you find 3?
from the meters.
Yeah, so our length has 3. That's right. Our
Yeah.
length has 3 significant digits. And what about the radius?
It's also 3.
It's also 3. So we have 3 in the radius. We have 3 in the length. We have 4 in the density, but we're limited, and pi has an infinite number, of course. So basically, we're limited to 3. So 1, 2, 3. That's where our and final answer has to be. So what's our final answer going to be?
I got a different answer.
Oh, okay.
I got 1608.722.
595.184 2.702. Oh yeah, 1608.187. Is that what you got? Actually, it's not even, that's not going to affect our final answer. So yeah, so it was 1608.187 grams. So here's our answer, and we need 3 significant digits. So 1, 2, 3. So what's our final answer going to be?
1,610 grams.
That's right. So we got an 8 here. That is bigger than 4. So we go to this number and we round up. So we have 1,610 grams. Excellent job. Yeah, so even if you'd made, a slight mistake with the calculation, you still get the right answer. So you would get, basically, you would still get full marks. You got the right answer, even if you make a little mistake along the way. It didn't affect it. So there you go. All right, this is basically the same question. So this is basically exactly the same question. So what bit of information do we need for this question? So it's asking us for length. So again, we're going to be using volume equals pi r squared L. This is a diameter, and on a circle, that's the diameter, right? From one side of the circle to the other. What's the radius? So if that's the diameter, what's the radius?
0.7.
It's half that, right?
Mhm.
So radius goes from the middle to the end. So there's 2 radii in a diameter, right? So our radius is 0.700 millimeters. So why do I have 3 significant digits here?
Because the diameter has 3 significant digits.
Exactly right. So you may be tempted to say, well, this only has 2 significant digits past the decimal. So the radius should have only 2 significant digits past the decimal. No, because we have, we want to keep the same number of significant digits. So there's exactly 2 radii in the diameter, exactly 2, so that's a count. So you want to keep the 3 significant digits. So what do we do with this bit of information? We seem to be missing something. Because basically we need to calculate a volume in order to get a length, but we can't calculate a volume with the information we have here, can we? How are we going to calculate a volume?
Need the density of copper.
That density of copper, exactly right. Because the density is always mass over volume. So if you're given the mass, you get the volume. So what is the density of copper? Copper is going to be a lot more dense than aluminum.
It's 8.96
8.96.
grams over centimeters
There
cubed.
you go. Numbers are useless without units. Exactly right. So 8.96 grams per cubic centimeter. So if we have 101.85 kilograms of copper, how many grams is that? Because we want grams, because the density is given in grams. So we want to get a mass in grams. So we're going to put grams on the top and kilograms on the bottom. How many kilograms or how many grams in a kilogram? Which one's bigger, a gram or a kilogram?
Kilogram.
Kilogram, right. By how much? How many grams are in a kilogram? 1,000. Absolutely. There you go. So that gives us 1,850 grams. Now, do I put a decimal at the end of 1850 or not?
Yes, because they're all significant. I don't know.
Are they? Take a look at the number of kilograms we have. How many significant digits in the number of kilograms?
3.
3, right. So do we put a decimal at the end of 1850?
No.
No. because there's only three significant digits there. So, all right, so I've got grams and I've got the density. So now I can get my volume. So 1,850 grams, I'm going to multiply that by something that will give me a volume at the end. So now I'm going to put my volume on the top. So my volume is going to be cubic centimeters on the top, and my mass goes on the bottom. So that's 8.96 grams. So what's my volume? How big a piece of copper do I have if I have almost 2 kilograms of it? The grams cancel, and I'm left with cubic centimeters. So this is what I want. I want a volume. So what's my volume?
$206.47.
206.47 what? 206.47 what? What's my unit?
Centimeters cubed.
Yes, centimeters cubed. So that goes into my volume. That's my volume. So that equals 206.47 centimeters cubed. And that's equal to pi times r squared. And my r here is in millimeters. So I want to convert that to centimeters. So let's do that. So remember, I can't be having different units. It won't make any sense. So we need to convert that to centimeters. So I put centimeters on the top and I put millimeters on the bottom. So how many centimeters, how many millimeters in a centimeter? We just did that one. 10?
10.
10, that's right. So basically we just divide this by 10. So 0.0700 centimeters. So that is our radius. So we're going to, remember, we're going to square that. 0.700 centimeters. Squared times L. That's our length. So L is what we're going to be solving for. So one of the things you need to be able to do in this class, pretty much any science class, but especially in chemistry, is algebra. Who hates algebra? Would that be everyone? Does everybody hate algebra? Because if you do, you're going to have a hard time. Because we're going to have this kind of problem a lot, where we're going to basically, we're given an equation, and instead of solving for this, we need to solve for this. So in that situation, we take both sides of our equation and we divide by everything that isn't L, right? What isn't L? Well, pi isn't L, and 0.00700 centimeters squared isn't L. So I need to, since one thing is equal to the other thing, I need to do the same thing to both. So I need to divide both sides by pi 0.700 centimeters squared. These things cancel, since I have it on both on the top and the bottom. Now you can see that L is equal to this. So 206.47 centimeters cubed divided by pi times 0.0700 centimeters squared. So what is that? And what's the unit? So 2 questions. Oh yeah, Abigail, yeah. 0.7 is millimeters. We have 0.07 centimeters because we want the same units. When we're calculating volume, they need all to be the same units. We need either cubic millimeters or cubic centimeters or cubic meters. They all have to have the same unit. So that's why we're using 0.0700 centimeters. So what do we get? What number and what unit?
We got 938.879 centimeters.
Right, so we have centimeters squared on the bottom, we have centimeters cubed on the top. So we divide that and we're left with just centimeters to the 1. So our unit is centimeters. And you have, I got a much different number. Let me double check.
Let me get
So 206 point, what's that divided by?
Oh, I forgot to
Yeah, I see what you
square
did
the,
there.
yeah, forgot to square
You
the,
need to square that, right? So your answer was right, but you need to divide it again by 0.07. So what's your final answer?
$13,412.
13,412.55,
0.5.
so 0.6. Right, so that is a length. You're not told what unit to give it in, so centimeters is fine. And it kind of makes sense that it would be a long length because it's wire, right? I mean, you can, when you flatten out metal, you can make a pretty long piece of wire. So it's a long piece of wire. So it's 13,412.6 centimeters. How many units, how many significant digits should we leave?
3 only.
3, right? Because initially our diameter is 1.40, that's 3. And our mass was 1.85, that's also 3. So we need to have 3. So here's our final answer, and there's 3 digits. So what's our final answer?
$13,400.
That's right, excellent. 13,400, and remember the unit, centimeters. So that would be 134 meters. That's a lot of wire. So makes sense though, because it's, if you had that much wire and it weighed almost like 1.85 kilograms, that's almost like 4 pounds of wire. That's a lot of wire. So it should be a long length. So any
Is that
questions about
100
that? Go
Is
ahead.
that 134.00?
No, it would be 134. You're absolutely right. You caught me. I made a mistake. Excellent job. Be 134 meters. Yeah, meters. It's 13,400 centimeters, but 134 meters. You're absolutely right. If I put the 134.00, that would be incorrect. I would dock myself some points for that. All right. I think this is our last one. This is basically the same question. So I'm going to let you guys work on this for a minute and then sort of come back. So here, I think I've given you, oh, I haven't given you the density of iron. I was a bad guy this week. So you need the density of iron for this one. Anyone have the density of iron? just like, you know, tattooed on the back of their hand.
7.874 grams over kilometers.
Sorry,
7.874 grams over kilometers cubed.
grams per cubic centimeter. Okay, there you go. So again, so this time we have the volume not of a cylinder, but of a sphere. So now our volume is 4/3 pi radius cubed. So that gives you a volume. So the diameter is 3.00 millimeters. So what's our radius going to be?
$1.50 millimeters.
That's right. It's going to be half. Yeah, radius is always half of the diameter. I always used to get this confused when I was in school with diameter and circumference and radius. So then I just left circumference out of it. Diameter and radius, 2 radius and a diameter. We're good to go. 1.5. You didn't have to have pi or anything in it, so it was easy to calculate. So, remember, so I'm going to let you guys work on this for about, I don't know, 5 minutes or so, and then I'll come back and see how you're doing. So remember, your volume needs to be in cubic centimeters. So remember that. And remember, if you have 10 kilograms of iron ore, that's 47% iron, and you recover all the iron from it, how much iron do you get? What's 10 kilograms times 47.0%?
4.7
4.7 what?
kilograms.
Yes. 4.7?
4.70.
4.70. There you go. So that is your mass of iron. You have 4.70 kilograms of iron. So you're going to want to figure out how I'm going to convert that to volume. And then once you've got a volume, you can go from there. So what I would probably do is figure out what the volume of one sphere is with a diameter of 3 millimeters. Figure out how much that would weigh, what would be the mass of that. And then pretty much then you can go from there. So if you have 4.7 kilograms of total mass, how many spheres does that represent? So is everyone clear on how to proceed with this, or you need a little more to go on?
I'm confused.
Okay. All right, let's back up a little bit. So basically the question, look at the question and you see what it's asking. It's what the answer is going to be is number of spheres. Whatever your conversion is, you've got to come down to like a number of spheres. It's going to be the end of it. So if your answer is number of spheres and you're given a mass and you're given a volume, well, the first thing to do would be to figure out what would be the volume of one sphere. So this is the formula for figuring out the volume of one sphere. Figure out what the volume of one sphere is. Once you know what the volume of one sphere is, then you use the density to convert a volume to a mass. Now you know what the mass of one sphere is. And then once you have the mass of one sphere and you have the total mass, you can figure out the total number of spheres. Okay.
Thank you.
Okay. So, okay, I'll let everyone chew on that for, let's say, I'll come back in about 12, 8, 12. And then we'll finish it up. Okay. I'll just pause the recording for a sec. Then I'll be back in a minute. I'll just leave that up. Okay. So does everyone come up with an answer? All right. So how far did folks get? Anyone get a number of ball bearings? Anybody?
I don't know if it's correct, Professor, but
Hey, I don't know if I'm going to get the right answer when we work this out. So we'll just put yours up in the corner here. So what did you come up with? I think it's quite a large number.
yeah, it's almost 42,700.
Okay. That
Number of
looks
ball
it looks
bearings.
about right. I think that's the proximate. Yeah, that looks pretty good. Let's go through. So how did you do it? So you started with the volume, right? So 4/3 pi r cubed, and then we know since the diameter is 3 millimeters, our radius is 1.5 millimeters. And when you convert that to centimeters, what did you get?
0.15. What?
Yeah.
Yeah.
0.150 centimeters. So it's 4/3 times pi times 0.150 centimeters, and then we're going to cube that. So what's the volume of one sphere?
I got a 1.41 times 10 to the negative 2 cubic centimeters.
Remember, you do not want to round early. Don't round. So you've rounded that to 3 digits, right? Don't do that yet.
Okay.
Because you want to, remember, you want to preserve, just use as many digits as you want. You want to preserve that precision. So it's 0.15 times 0.15 times 0.15 times 4 divided by 3 times 3.14159. Oops. So that is 0.014137 cubic centimeters. So that's how big one ball bearing is. Okay, so we have this number. So we have a volume. And we have the density of iron. And just remind me again what the density of iron is. What was our density of iron?
7.874 grams per centimeter cube.
Where are we? 7.874 grams per cubic centimeter. Well, we have a cubic centimeter now. So this is our volume of a ball bearing. This is the density of the material it's made from. So it's made from iron. So I have mass on the top. I have volume on the bottom. And so when I multiply that by our volume, 14137 cubic centimeters, our volumes cancel out and we're left with mass. And that's really kind of what we were looking for. We were looking for the mass of one ball bearing. And so carrying all our significant digits, remember, because you never round until you get to the very end. 7874. So that is 0.111316 grams. So that's the mass of one ball bearing. And remember, we want our final answer to be in number of ball bearings. So what do? We take the total mass. So our total mass of iron was what? How much iron did we have to start with?
$4.7 kilograms.
Right, 4.70 kilograms. So we had 4.70 kilograms. And we want grams, right? Because we want the same mass. So we're going to convert kilograms to grams. So how many grams are there in a kilogram?
1,000.
1,000, that's right. And the other thing, the other conversion we're going to do is ball bearings to grams, because that's what we want. One bearing is 0.111316 grams. So I get rid of my kilograms, I get rid of my grams, and what am I left with? The only unit left, ball bearings. Of course, it looks more like bet rings, but or Bettina or something. I'm left with ball bearings. So 4.7 times 1,000 divided by 0.111316 gives me number of ball bearings. So I think you're right. I think it's like 42,700. 47,000. Oh, no, 4,700. Sorry. 3, 4, 6. Yeah, 42,210.77. I may have made, did I make a mistake with that? Is it 42 or 40, 42.7 or 42.2?
I got 42,205.459.
Okay, all right.
I got something different. I got 42,222.14. I think because you put 111346 instead of one.
Oh, I probably did. Yeah, that does look like a 4. I think that's what I did. Yeah. But either way, how many significant digits? So that's the number of bearings. So our unit is now bearings. So how many significant digits should we have in our answer?
3.
3, right. There's 3 here in the mass. There's 3 here in the percentage of that mass that's iron. And there's also 3 in the diameter. So our final answer should have 3. So 1, 2, 3. So what's our final answer?
42,200.
That's right. Yeah, so I think where the 42,700 came from was rounding too early. Yeah, you did everything right, except that you think you rounded the volume. Yeah, don't round. Yeah, I think you rounded this to like 0.014 or something, which just throws off your, I mean, it just throws off the answer just by a little bit, but just that little bit, makes a difference. So yeah, final answer is 42,200. Great job. Everyone see how that works? This is a hard one. This would be like on a final, because there's a lot going on here. There's a lot to think about. So if you can
I'm
get,
still kind of confused how you got it. So I got up to you figuring out the volume.
Mhm.
And then after that, it kind of became confusing.
Oh, okay, no problem. So this was our volume.
Yeah.
And we need to convert that to a mass. Because basically we're given a mass. We're given a mass of iron, not a volume of iron. We're given a mass of iron. And so we need to convert the volume to a mass. And we did that with the density. Yeah, I sort of erased that a little while ago, but we just multiplied the volume here, this volume here, by the density, and then turned it into grams. So the volume in centimeters cubed became grams. I think the density was what, like around 9 or 7.8, something like that.
Yeah.
Grams per centimeter. Yeah, so using this density, we take the volume and convert it to grams.
So you just multiplied 7.8 by 0.01413 centimeters cubed.
Yeah,
You cancel out the
we
7
multiplied
and you get the-
this density by this volume. And so centimeters cubed goes away, and we're left with grams. And that's this number down here. That's this number here.
Oh, okay.
The 0.111316. So that's the mass of one ball bearing.
Okay.
Yeah, my handwriting is atrocious. Yeah, so that's the mass of one ball bearing. So if we have the total mass and we have the mass of one ball bearing, then we can figure out how many. And then basically we just use this as a conversion factor. One ball bearing is equivalent to 0.111316 grams. And so then we have the total number of the total mass. We have the mass of just one, and we just figure out how many ball bearings we could get with that.
And
Okay.
then you use the iron ore, the 47%. You
Mhm.
converted that.
Yep, that's where our
Gram.
4.7 kilograms of iron come from.
Okay.
That's 4.7 kilograms of iron, because we had 10 kilograms of iron ore, but only 47% of that is iron. So if we get all the iron out of 10 kilograms, that leaves us with 4.7 kilograms of actual metal.
Okay.
Yeah, that's why I said this is a really hard question, because it's got a ton of things, ton of information in here. And so, yeah, this is like, would be worth like, 10 points on a final. And then give you lots of time to work on it. But, if we do the hard questions, together, then, they're all going to be easier when you do them by yourself, hopefully. Evil. Yeah, a little bit. But yeah, that's why I want to, if I throw you some curveballs during the group sessions, then, then fastballs are going to look easy when you get them on a test. Any other questions about this or any of the other problems we worked on tonight?
Oh, sorry.
Oh, you can go first.
Okay. Professor, I just want to make sure it's 4.70 times 1000 divided by 0.111316, right?
Yes.
But I did it, but it says mine in my calculator says 42,222.14. I'm not sure.
Oh, yeah, so let me, all right, so it's 4. If I have, man, if I erase this now, I'm never going to be able to find it again. So I think the problem was, yeah, that's a 1. That's a 1.
Yeah, I did put 1 on it, but
Okay, yeah, I mean, it's quite easy. It's that I have made a mistake by punching these numbers in. So 4.7 times 1,000
times 1 on divide.
divided by 0.111316. Oh yeah, you're right. 42,222.14, right?
Yeah.
Yeah. Yeah, that's right. Yeah, see, I told you, I make mistakes constantly. So you should always be double checking. So the good news is, yeah, I think the problem was, yeah, I put a 4-6 in there. I put 111,346 because I stupidly put a cross into there that made it look like a 4. So yeah, 2.14. But the good news is it makes no difference to the final answer. Get the same answer, 42,200. Yeah, it's always good to double check your numbers, especially with a question like this, where there's about 6 to 8 different calculations you're doing. So that's why I like to have like a big, long piece of paper and just start from the top and go all the way down to the bottom. Yeah, so I had to erase some things in order to just to make room. So it's kind of easy to make a mistake like that. Any other questions on any of the previous problems you still don't understand?
I have a question for question 2D.
Okay.
So would we be able to the exponents, leave them all as 15 or all to the exponent of 16?
2D.
Uh-huh.
Okay. Right. So with this one, so what would your question was? What was your final answer?
I think I got 8.72 times 10 to the 15.
Yeah, that looks right. Yeah, so you can do one of two things. You can either convert everything to 10 to the 15th, or you convert everything to 10 to the 16th. Do one or the other. So yeah, so then you have 8.000 times 10 to the 15th. When you convert this to 10 to the 15th, then it becomes 0.720. So 0.720 times 10 to the 15th. Right, so you're 8.720 times 10 to the 15th is correct.
Okay, thank you.
Yep. Well done.
That's weird. I got 8.00 times 10 to the 16th for that answer. Are you supposed to
You're adding. Remember, you're adding here. You're not multiplying.
Oh, okay. So you do you kind of treat it separately? So 8.000 plus 7.20. So you add that.
Mhm.
And then in terms of the exponents, you either go up or down.
Well, you haven't gone over 10, so you don't change the exponent. If let's do it the other way. I'll show you what I mean. Let's change everything to 10 to the 16th. So here I would have 80 times 10 to the 16th plus 7.20 times 10 to the 16th. So when I added these two, I'd have 87.20 times 10 to the 16th. But we can't have a number bigger than 10 here. It's got to be between 1 and 0, 1 and 10, right? So I divide this part by 10, and I get 8.720. And since I divided that part by 10, I need to multiply. Oh, wait, I did this the opposite way. Oh, wait, I screwed this all up. Never mind. I got the wrong one being bigger. That's on me. So 7, whoops. 7.20 is 10 to the 16th. That's 10 times bigger than this. I was thinking of it minus. So that must be getting late. So 7.20, if I change everything to the 16th, then this becomes 0.8000 times 10 to the 16th. Because if you divide this side by 10, you need to multiply this side by 10. So that becomes 0.8000 times 10 to the 16th. Now, when I add them, I get 8.0000 times 10 to the 16th, but I can only take 3 digits past the decimal point, or 2 digits past the decimal point. So my final answer is 8.00 times 10 to the 16th. Sorry, I got that
Oh,
one.
so my answer was correct. Okay, 'cause
Yeah.
I was like, why did someone else get a different?
No, I screwed it. I screwed that up. I have a slight, well, it's not that embarrassing. I have a slight case of dyslexia. And so numbers will sometimes flip around on me, and they did there. I put the 15 on one and the 16 on the other. So yeah, I need to watch myself when I do these problems. It's weird. It happens with numbers. It also happens with letters. I get B and D mixed up all the time when I'm writing. One will just go into the other. That happens all the time. So if I make mistakes like that, you'll know why. Yeah, so 8.00 times 10 to the 16th is the right answer. I had the wrong number being larger.
Oh,
Man, so I'm glad you asked, because yeah, that would have sent you away with the wrong answer. I don't want to do that. So any other questions before we wrap it up?
Professor, can you go back to letter E?
2E?
Yeah, I got confused with the scientific notation part here.
Okay. Oop, 2E? Is there
No,
an E?
I'm sorry, letter E.
Oh, letter E.
Yeah.
This
the
one.
nano.
Oh, changing nanometers to kilometers?
Yeah.
Oh, sure. Okay. So we 5.51 times 10 to the 17th nanometers. Now, the way I like to approach this, instead of going right from nanometers to kilometers, because it's really easy to make a mistake there, is go to meters. So I want to get rid of my nanometers and replace it with meters. So how many nanometers are there in a meter?
So it's
Or
going to be,
meters in a nanometer, either one.
is it 1 meter is equivalent to 1 times 10 to the -9 nanometer?
Plus 9. Because remember, nanometers are really, really small. And so there's 10 to the 9th of them, because they're so small, in 1 meter. That's the part that's really easy to get backwards. Nanometers are really, really small. So there's actually 10 to the -9 meters in 1 nanometer. So if you do it the other way, that means there's 10 to the 9th nanometers in 1 meter. That's where the confusion comes, I think. It just depends which one do you want to make 1 and which one do you want to make not 1. So nanometers are really, really small. So they have to be much smaller than the meter. So if you put 1 meter, you have to have 10 to the 9th nanometers on the bottom. Okay. Have I lost you already?
Okay. And then we have to convert that to kilometers.
Yep.
From the 1,000 meters.
So one more. So we get rid of the meters this time, and we put kilometers or kilometers on the top. So how many meters in a kilometer?
1,000 meters.
Yep, in 1 kilometer. So basically, This is 10 to the 9th. This is 10 to the what? 1,000 is 10 to the what power?
3.
3. So I've got 10 to the 12th down here. So when I multiply these two together, I get 10 to the 12th. So if I divide this by 10 to the 12th, basically I just subtract 12 from this, and that becomes 5. So my final answer is 5.51 times 10 to the 5th. And then the unit is nanometers are gone, meters are gone, kilometers are left. And we just keep, this number stays exactly the same. You don't do anything. The significant digits don't change at all. The only thing we're changing is the factor of 10. That's it. That's all we're doing. So you don't need to worry about the factor. It's just the exponent that changes.
Thank you, Professor.
No problem. So I see number 3B. Audrey, you still with us?
I'm here, Professor.
Did you want to look at that one again?
Yes, please.
No problem. All right, 3B. Okay, yeah, so this is something that we're going to be doing starting tomorrow, actually. This is probably the most important concept in the entire class, is the concept of a mole. What is a mole? So 1 mole of something, that's basically a chemical amount. That's all it is. It's just an amount of a chemical that reacts with an amount of another one. And we will learn that it's sort of taught in class usually that a mole is equal to 6.022 times 10 to the 23rd atoms. It's a lot of atoms, but I don't care how many atoms it is. What's important is how much it weighs, because we can weigh something. We can actually determine the mass of something. We can't count atoms. No one in the world can count atoms. We can measure grams. And so all a mole is that, and we'll learn tomorrow, is just the atomic mass of all of the atoms in a molecule. So in water has 2 hydrogens and it has 1 oxygen. The atomic mass of hydrogen is a little over 1. The atomic mass of oxygen is a little less than 16. And so when we add these together, we get 18.15. And that just happens to be the number of grams that are in 1 mole. Because there's 1 mole of oxygen in a mole of water, and there's 2 moles of hydrogen in a mole of water. It's just a chemical amount. That's all it is. And we're going to be doing a lot of these calculations, because when we do a chemical reaction, we can measure the mass of something. And so scientists long ago found that when they reacted a certain mass of hydrogen with a certain mass of oxygen, they got a certain mass of water. And they were able to see the difference was, for every 18 grams of water that they made, about 2 grams of it was hydrogen and about 16 grams of it was oxygen. And so they figured out that, well, a mole of hydrogen, since there's 2 of them, must be around 1, and a mole of oxygen must be around 16, since there's only 1 mole of it in there. And that's how they figured it out. So, well, like I said, we'll deal with more of that tomorrow. But all you need to do right now is convert one to the other. So if we have 500 grams of water, we're just going to convert that to moles. That's it. So how do we do that? What's the conversion factor between grams and moles for water?
You put 1 mole on top and then
Mm-hmm.
0.15 grams on the bottom.
Perfect. Exactly right. Yeah, 18.15 grams. Like I said, because we can't measure moles. We can measure grams all day though. I mean, you're going to have, hopefully, if you have your lab kit, you've got a little balance in there, scale. And so you'll be able, if you have any of the different chemicals that are in that kit, you'll be able to measure the mass, and immediately you'll know how many moles you have. And once you know the number of moles of something, everything else is pretty straightforward after that. So all we need to do is do this conversion, and believe me, you're going to get tired of this. You're going to be doing this conversion, forever and ever and ever. So grams cancel, and we're left with moles. So all it is 500 divided by 18.015. So how many moles is that?
Um, 27.8.
So give me all the digits.
27.
27.8, keep going.
Moles. Oh, sorry.
No, but how many digits?
0.75.
27.75? Okay. So now we figure out how many significant digits, right? So how many significant digits should our final answer have?
3.
3.
That's right, because there's a period, there's a decimal there. So all 3 of those are significant. There's 5 significant digits in the molar mass. And that's what we call this, a molar mass. It's just the mass of 1 mole. Imagine calling it that. Yeah, so 3 digits. So here's our final answer. There's our 3 digits. And you rounded it to 27.8, right?
Yes.
That is correct. Well done. Yeah, so we will deal with moles pretty much every class for the rest of the term. So now, believe me, that is the most critical thing to take away from the whole class is the concept of moles. Some people get it really, really quickly. Other people take a long time. I'm constantly straining to come up with better ways of explaining it. Yeah, the best way I could think of it is, yeah, it's a chemical amount. Like an amount of eggs is a dozen. An amount of oxygen is a mole. That's it. So, I mean, if you can come up with something better for me by the end of the term, that would be awesome. Any other questions?
C.
Sorry?
What is the speed of a train traveling 118 miles an hour in meters a second?
Okay. Did you come up with an answer for that one?
I think it's 265.5 meters a second.
265.
I'm not sure. I got really confused because I knew you had to convert miles to meters and hours to seconds, and then I started multiplying and everything all wrong, so my numbers.
Yeah, that's why I like to write it out and then you can either do all the conversions at once or you can do them one at a time. Either way, but I always like to multiply because then I could follow the units. So 118 miles, or MIBs as it says here, in 1 hour. So the first thing to do would be to convert hours to seconds, right? So I want hours in 1 hour. How many seconds are there?
3,600.
Yeah, 60 times 60. So there's 3,600 seconds. So that gets rid of my hours, and I've got seconds. The next thing, I want to convert miles to meters. So I think there is a conversion for kilometers, miles to kilometers in the ones I've given you. If there isn't, then you can just look it up. That's fine.
1.0000 mile equals 1.6093 kilometers.
Sorry, what was that?
1.0000 mile equals 1.6093 kilometers.
So 1 mile is 1.6. How many kilometers?
1.6093.
93?
Yeah.
Okay. Kilometers. Miles. All right, so we've gotten rid of our hours. Now we need to get rid of our miles. So there's miles. And so what we've got now is kilometers per second. So we're really close. The only thing we need to do now is to get rid of kilometers. So we're going to put kilometers on the bottom because the question is meters per second. So I'm going to put meters on top. So how many meters in a kilometer?
1,000 meters.
1,000, right? That's what kilo means 1,000. So now miles are gone, hours are gone, kilometers are now gone. And what units do I have left? The only units I have left are meters on top and seconds on the bottom. And that's exactly what I want. So now I just multiply 118 times 1.6093 times 1,000, and I divide it by 3,600. And that gives me the answer in meters per second. So let's see what that is. So it's 118 times 1.6093 times 1,000 divided by, nope, I've already screwed it up. 1.6093. So I got 57.7493. 7493. And the units are meters per second. So then the question is 57.7, right?
About 52.7492.
I don't even trust my finger anymore. This is
I got
terrible.
the same thing.
You got the same? So you got the same as
me too.
57 or 52?
52.
Okay.
52.
18 times 1.6093. Yeah, you're right. 52. Man, why do I keep making these mistakes? This is pathetic. 52.749. Okay, 52. So we have the right units because everything else canceled. Miles canceled, hours canceled, kilometers canceled. And my only units left were meters over seconds. So that's how we know we did the job correctly. As long as you didn't screw up any of these conversions, we're going to have the right answer. And that's why I want you to do it this way, because on a test, if I see you set it up correctly and you make a dumb mistake like I have all night, you'll still get the majority of the points. Now, the only question is how many significant digits should we report? 3. Right, 3. Even though there's only 2 significant digits in 3600s, there's exactly 60 seconds in a minute, and there's exactly 60 minutes in an hour. So those two are exact numbers. So 3 digits. So here's our final answer. There's our 3 digits. So what's our final answer? 52.7. That is correct. Yeah, so don't be tempted to round that 4.9 into a 5. And then once you've done that, then this becomes an 8. No, Don't do that. Just look at the next number, because 493 is less than half, right? So if it's less than half, then you can't round up. So just leave it at 52.7.
And will you give us more problems like this? Because, you know, I tried doing the ones in the book and they were fine, but then the ones in the book were a lot easier than the worksheet you gave us. So
These are two evils, what you're saying.
you're trying to torture us, you know. No, I'm kidding.
What I can do, yeah, I mean, if you really want,
I'm sure this will be on the exam. These
stuff
kind
like
of
this,
conversions
stuff like this. Oh, there'll be a ton of them. Yeah.
Yeah. So, you know, I'd love to get more practice.
Sure. Yeah, I can post some with, yeah, I mean, it's easy to find some online. It's really easy to find some online. There's also some you can do in Chem 101. So I could send people to Chem 101 for some practice.
And whenever
Why didn't I do that? That'll get you familiar with Chem 101 as well.
Oh, and whenever you send things via Chem 101, will you just announce it in the announcements?
Oh, of course. Yeah,
Okay.
yeah, because I don't think I can actually send you a message through Chem 101. It has to be through Canvas.
Oh,
So what I'll do is I'll say, yeah, there is a, you know, practice test you can do with these sort of problems. That's a really good idea, because that way it gets you familiar with Chem 101 in a sort of non-threatening situation. And then, yeah, whoever needs the practice can do it. It'll be completely.
oh, you can do it as extra credit.
I could do that. Yeah, good idea.
And this might be a dumb question, but for exams, other than the exam reference sheet, that's all we got, right?
Yep, that's it. And a
Okay.
calculator.
And you can't, do you proctor it? Like, do you actually watch us as we're taking it?
No, I'm going to trust you.
Oh, okay.
I much prefer trust.
Because I know some teachers, they're like, no, we're recording you as you're taking the exam to make sure you know.
Yeah, no, I don't like the big brother thing.
Oh, I see.
I'm uncomfortable with it. I think you'd be uncomfortable with it too, wouldn't you?
It's been
But are
done
you still
before, but
giving
that
us
was for
the
like a state
other?
exam.
I think it's just better that we trust each other. I think that just,
Oh, okay.
to me, because I mean, because we can see actually when there's plenty of sites you can go that like, or tests like this are actually like worked out for you, and we can actually see in real time people doing that.
It's kind of crazy. How you
So
like
yeah, I
figure
don't
that
need
out.
to. I don't need to be watching you. We can tell. We have our ways. Yeah. So
Will
I
you
don't.
still give
I
us
don't
the
like doing
other?
that.
Sorry, Professor. Will you give us the other conversions that we can use though? Because I remember you saying that you didn't want us
Oh,
to have to
sure.
memorize them.
Yeah. Actually, yeah. That's a great point. I will find the rest of the conversions and include them. But I think most of the ones, that'll be on tests are already on the sheet. So, I mean, I won't be asking you questions about like miles and kilometers, because who cares about that? I mean, we're more interested in units, mass, volume, and moles. That's pretty much it. Those are the three things we're really interested in: mass, volume, and moles. So yeah, we're not gonna be dealing with like inches and feet and stuff like that. So most of them are already on there, but I will add some of the ones we've done tonight that we didn't know. So I'll put those on there, like miles, kilometers. What was the other one? I think there was another one that wasn't on there that we needed. Oh, liters in a
Kilograms to-
gallon. Yeah, liters to a gallon we needed. So I'll include that as well. All right, anything else?
So, Professor,
Oh,
in
sure.
submitting this worksheet for tomorrow, so we can just go ahead and just show our computation or like solution for every number, and then just take a picture of it and then send it.
Yep, that's the
Okay.
best way to do it. Mhm.
Okay, thanks.
Yeah, no problem.
And to prepare for the lab for Wednesday, is there anything we needed to do?
I'm sorry?
To prepare for the lab on Wednesday, did we need to like read something or?
Yeah, read the instructions. They're in
Or,
Canvas.
I know that you there's that intro to graphing that we had us do. So is it that what did that be due during?
No,
lab
this is the
time?
next lab. This is it's density. So that is the next one in Canvas. That's lab number 2.
Oh no, I mean the lab where we had to do the graphing
Oh, what
on
about it?
the is that due this week on Wednesday
Yes.
or Thursday? Okay, yeah.
Mm-hmm. Yeah, that would be due Wednesday at midnight.
Okay.
Yeah. Yeah, you have a week from the end of the lab. Yeah, so read everybody read lab number 2 and have everything ready Wednesday. So
And I believe
it lays out like, you know, all the stuff you'll need. So read it beforehand, have all the stuff ready. There are certain things that aren't in the kit that you'll need, like white sugar. So hopefully you've got some white sugar in the house.
and I believe you want us to face our camera on Zoom during lab, right? You want us
That'd be best. I mean,
okay, you want us to you want to physically be able to see us as we're doing the experiment, correct?
yes.
Okay.
Yeah. I mean, if it's you know, difficult or impossible, I mean, we're not dealing with anything hazardous tomorrow. So it's not as
So no
important.
safety goggles. No, I'm just kidding.
No, you need those.
No, I was just kidding.
No, those you need. But yeah, because man, if you got sugar in your eye, I mean, my God, you'd be blind within seconds. So
Oh, I thought you were gonna say, what was it?
what was
I
that?
don't know. I thought you were gonna say something like one of the acids that we have.
No. Yeah, no, we won't be doing anything with the acid till later. But yeah, tomorrow's just sugar and water. So
Oh, okay.
there's no problem with that. But you still need to wear your goggles. That is that's non-negotiable.
Okay, yeah. I see that.
Yeah.
Professor?
Sure.
I have a
Yes.
question.
Mhm.
So do we have to have our cameras on during the Zoom for like the lab so you can see what we're doing?
Yes.
Okay, thank you.
Mm-hmm.
Professor?
Mm-hmm.
For the handwritten graph, do you want us to put the regression line for each plant?
You just draw your own. You draw your own best fit line. The regression line will be, because yeah, you can't do a regression by hand, but you can do like your best guess. You get the actual slope from the computer graph.
Okay, but on the instruction, it doesn't say, oh, draw the regression line.
It doesn't say draw a line at all.
No.
No.
Oh, well, if it doesn't say it there, then don't.
Okay.
But you know, if I can't graph anything without trying to draw a line. I mean, that's just, you know, it's my OCD acting up. You know, if you got a whole bunch of points on a line, I got to try and connect them somehow. So either way, if it doesn't say to do it, then you won't get docked for not doing it.